So for instance, whenever we're factoring a quadratic, we always want to do the golden rule first and see if there's something I can take out. If there isn't, okay, we always can go back to our old faithful things that we know about. Like 4. We're like, sweet, there's nothing in front of x squared. What two numbers multiply to 63 and add up to negative 16? If you're not sure, this is where we need to keep working on the multiplying facts in our brain, kind of. Well, here's one thing I know. I know to get a positive 63, they either both have to be both negative or both positive. Well, I see that's a negative. 9 and 7. That's all the further I need to go. Now, will that always be the case? No. Okay. If we even move the one right below it, number 6. Those two things have anything in common? K. So if I take out a K, what do I have left? 7K plus 9. Can't go any further. So that time I can only take out a greatest common factor. That was the biggest piece of factoring that I could do. Right. Sometimes, right. So, yeah, we just kind of keep going. Now, you'll notice in some of these, as we get a little further, sometimes we may be able to take something out and be able to factor it. It just kind of depends. Oh, yeah, we're going to. So, for instance, I get to 8. Do all 3 of those terms have anything in common? No. Unfortunately, no. So then what do we do? We say, well, I'd be able to take out a B if this also had one. But since all my terms don't have one here, I'm either going to have to do some mental math or I'm going to have to slide and divide. Okay, either one works. So if we go to slide and divide, I now need to find 2 numbers that multiply to 42 but will add up to 17. Six and 7 do 42. They don't quite get me 17 though. Yeah, that's okay. Dig deeper. They're thinking of smaller numbers that could possibly go into 42. Because we need them to be able to add up to 17. If need be, bust out the calculator, start trying numbers. Some of you think factoring 6 and 7 would add up to 13. No, multiply 42. We're on the right track. They're going to be further apart. 3 and 14. But again, this is not just the slide method. You must go back and divide. Nope, if you put the 14 first in the 3, that's absolutely okay. If your fraction is in its most simplified form, yet it still does not turn back into a coefficient, slide that guy back to the front. But if it does simplify, 14 divided by 2 is 7, then there's no need to slide it back. And I've got it. So you're like, dang, 3 problems, we've done a diamond. We've done it just a greatest common factor. We've done a slide and divide. Now let's find one that's a little bit odd, like 10. Like, oh crap, Harty, we haven't done stuff with like the 4th and 3rd. What you doing? What do those 3 terms have in common? N squared. We always want to take out the smallest exponent we see, but it can be bigger than just n itself. What about as far as the coefficient goes? Is anything divided into all 3 of these? Bigger than 2, but 2 absolutely would be a number that would. 8 works for these 2, but not for 28. Now we can come back a little. 4, okay? So if I take out the GCF, 4n squared, now we've got to work with whatever's left. So how do I get from 4n squared to 28n to the 4th? Okay, 7n squared. 4 times 7 is 28. 2 plus 2 is 4. Working my way through here. So I get the 16n to the third for n. 4 times 4 is 16. N squared times n is n to the third. Last part. 4 times what to get me to 80? Wait. So now the fun begins. I have to see if I can factor what's in the parentheses. I'm going to ignore this for right now, my 4n squared. Why did I take the n off of this one? So I already have n squared here, so if I do 4n squared times negative 20, there's my negative 80, but I've already got the n squared. Sure. Well, I can't take anything else out of here, but I could try sliding and dividing to see if I can simplify it some more. So for instance here, some of you are like, oh my gosh, Harty, you're going to get us into triple figures. Yes. I'm purposefully going to get you into bigger numbers to get you to play with these. And yes, this one factors. There may be one or two on here that don't, but this one does. I need two numbers that multiply to negative 140, but add up to 4. Nice. Which one gets the negative and which one gets the positive? Nice, alright. So if need be, you'll have to play with these a little bit, but you'll notice, oh, they're like 4 apart. Okay, I can see how this works. But then again, get that 7 back through, and what we end up finding out here at the end is, my answer is that greatest common factor that I pulled out at the start. 14 divided by 7 is 2. 7 doesn't go into 10, so it swings back to front. Dang hard. Getting kind of complicated. What it's doing is it's going to keep pushing you on your greatest common factor. Okay, now how can I factor it? Okay, now I got to watch the detail here. I'm really going to press the detail with this one. The one other one I want to look at, because it seemed to freak people out first hour here on the front, was 13. They're like, now you're throwing 2 variables in. Why are you doing 2 variables? They won't be 2 there for long, at least not that they're going to bother us. What do all 3 of these terms have in common? I agree with B. Anything else? Something may divide into all 3 of those, but kind of small. 3. So if I take out a 3b, watch what happens. I've got 10n squared, but I already have the b, so that first term's not going to have a b. Okay? Yep, I'm just multiplying to get my first term back. 3 times negative 29 gets me negative 87. I already got the b, so I just need the n. 3 times 10 gets me 30, and I already have the b. So the part that I actually have to factor only has n now. And again, I'd go back through and I'd slide and divide and I'd work through it that way. But that's just to kind of give you a forewarning. There's lots of little things that can get done here, but as long as I'm finding that greatest common factor first, that's basically all we're looking for here. So on the front, it's just factor. When you flip over, though, okay, there gets to be a little more to it. So let's talk about when we solve your equation. Well, okay, but I don't want to do that. Because on these, I want my equation to have to be 0. The nice thing about the first 4 of them they're factored already. So all I have to do here is take what's inside the parentheses, set them equal to 0, and solve them. I don't have to do anything else. So please don't FOIL this back out, because then you're just making yourself more work. So those first four should be the easiest four probably, except for maybe some of the diamond problems on the front of anything in here. But when I wrote up at the top the equation has to be equal 0, what I was referring to are problems, let's say, like number 5 or number 6, or basically anything going down the rest of the page. If I got down to number 5, when I say it has to be equal 0, that means anything that's over here, we're always going to move everything to the squared side. So I'm going to subtract this 33k over to the left side so I have it equal 0. So I can actually factor what's left. You want to avoid negative squared terms. So like for instance, I'd still have to factor 5, but like if I was doing 6, I wouldn't want a minus n squared, because if you have negative n squared, that gets hard to work with. You want to bring everything to the squared side. So add the 9n over, add the 18 over, and get your equals 0, and factor it. But always, always, always keep that squared term positive, because otherwise it becomes a real pain in the butt. But basically for the rest of this, that's what you're going to be up to. Get it all to one side where it's equal 0, and then factor it. So it might be a diamond, it may be a greatest common factor, hint, that may make life easier on you as long as you remember it. Now, could you slide and divide on that? Sure, but wow, I really don't want to deal with 216 and negative 33 if I don't have to. So we're really going to push at attention to detail on this in trying to help you out with just getting used to this. So when we keep bringing up factoring in section after section after section in here, it's not one of those things where you want to say a different F word when you see it. Okay? So that's basically where we are at right now with these. Are there any other types on there that you're kind of looking and saying, okay, wait a minute, this was kind of weird. I think I hit the different one. This one? Okay. Push this up a bit. Alright, so 9. My first job is to get all of my b squareds together. That's why I got b squareds on both sides. Okay, so here's my next thing to think about. Is there a way I can move it where my b squared is in a positive? Well, yeah, if I move this 3b squared over here, that'll give me a positive 1b squared. That's a good thing. So I guess everything is going to move to the left in this case. Those go away. I did opposites to move them. Negative 2 plus 3 is 1. 1 minus 6 is negative 7. And all of a sudden, that becomes a lot easier to work with. But just keep that squared term positive. If you do, these should be much, much easier to deal with.